The elimination of the open flame is one of the most consequential technological developments of environmental tempering. However, before the separation of flame and heat, raw or partly processed fuel was readily pumped into households to supply a messy flame. Gas lamps were essentially medieval candles, with house program designed around the primitive fire. The technology of the mid-19th century couldn't offer more than the radiator, which was at the mercy of draughts, open windows, local convection from lamps, furniture obstruction. Nor the technology of the fireplace. What began to change, however, was the separation of combustion gases from air warming the spaces. The ability to duct hot air into spaces meant that the stoves or furnaces could be located elsewhere. Heating and ventilation were planned together, and most systems used the laws of convection to move air. This presented a problem. The heating that was effective over the colder months didn't work during the hotter months because the convective flow went out the window. It was the period after 1860 that fan-forced ventilation began to flourish. But there was an enormous barrier. There was no fresh air to draw from. Ventilation technology came to a halt because of pollution. One of the largest contributors to this pollution was gas lighting. Gas lamps at the time produced city wastes because it was the airborne carbon residue that incandesced. Welsbach's gas mantle provided a solution. The mantle incandesced, allowing the flame to burn cleanly and efficiently. However, this innovation came too late. The electric lighting, which was awaited with religious awe, quickly took the spotlight. It wasn't until the invention of Edison's domesticated electrical grid that these other technologies were able to get over this barrier. Fan-forced ventilation technology became more democratized, and the new electrical lighting posed no significant problem to convective heating.